4, which is more multiplication properties of exponents. Today we're going to talk about raising a power to a power and raising a product to a power. What does that look like? So the first objective for this first part, just understanding raising a power to a power. Here we have a to the m, and everything inside this parenthesis to the power n. So the shortcut that we're learning today is that you can actually just multiply these two exponents together because it's the same base raised to a power to a power. So when you're raising a power right here to a power right here, all you do is you multiply the two together. So let's take a look at these examples. 5 is my base, 5 to the 4th squared. So the rule is that we can just multiply these two, which you can see is done here. 4 times 2 is 8, so my answer is 5 to the 8. Now let's look and see what this is, why this works. So if we take a look here and we have 5 to the 4th, which is 5 times 5 times 5 times 5, we have all of this squared. That means we have two of them. So we have 5 times 5 times 5 times 5, and now we have another one because this is really this twice. 5 times 5 times 5 times 5. Well, what is that? How many 5s do I really have? 1, 2, 3, 4, 5, 6, 7, 8. So I really have 5 to the 8, which is the same thing here. So over here, now we're using with variables. We have x squared, everything inside. So these parentheses are going to be huge throughout today's lesson. Raised to the 5th. So power raised to a power, multiply their exponents. 2 times 5 is 10. You use the same base, and we have x to the 10th as my answer. Let's do another example. A to the 3rd raised to the 4th. So everything inside this parenthesis gets a power 4. So it's a to the 3 times 4. 3 times 4 is 12. So my answer is a to the 12th. Another one. So this is where we're talking about that parentheses gets a little more important. To rewrite this, we have b squared times parenthesis b cubed raised to the power of -2. Well, what could I simplify so far? Everything inside this parenthesis is going to get the -2, alright? So power raised to a power, what do? Multiply it. So we have 3 times -2. That's going to give me b to the -6. Now I have b squared and b -6 left. So let's see what follow what they're doing. We need to simplify that yet. So like I said, power raised to a power. It's inside this parenthesis, so that's how we know it belongs to them. Now 3 times -2 is going to give you b to the -6. Now from yesterday's lesson, same base, and we're multiplying. What are we going to do with these exponents? Yes, we add them. So 2 plus -6 gives you -4. So b to the -4 is my simplified answer. Now, can we have negative exponents? That's from the very first section of this chapter. Nope. We put it all over 1. So 1 over b to the 4th. Because I put it over 1, it's now made this positive. So I have b to the +4. So now I'm raising the second objective for today here is raising a product to a power. So now inside my parenthesis I actually have two variables and a multiplication sign in between. What we're going to do is we're going to distribute this n to both because of this parenthesis. So in that last example we had a b2 out here, and that did not get part of it because, like I said before, these parentheses are huge. So everything inside these parentheses do get raised to a power. So let's take a look what this is saying. I have 3 times x to the 4th. What this is saying is that you can take your your n here and distribute to both. So I had a times b to the nth. Give it to both. We have a to the nth times b to the nth. Same, let's look at this. Let's go back to this example. 3x to the fourth. What is this saying? Well, you have 3x 4 times. So how do I rewrite that? 3 times 3 times 3 times 3. Well, I have 3 4s. 1, 2, 3, 4. And 4 x's. So that's a simplified way. What they're saying is the shortcut is just to distribute to both. 3 to the fourth, x to the third. Now, can I simplify this 3 to the fourth? Yes, you can. 3 times 3 times 3 times 3 is 81. So my most simplified answer is 81x to the fourth. Let's take a look at another example. So inside my parenthesis, I have 2 terms, 4 times x cubed, and I need to square this whole thing. So the shortcut is distribute that squared through. So, as you can see here, they took that 2, gave it to the 4, and then as well x to the cubed. Now, this is a power raised to a power, which is the first part of today's lesson. So what do? What we're going to do is we're going to multiply those exponents. So 3 times 2, right here, power raised to a power, you multiply them, gives you 6. So we have x to the 6, 4 squared. You can simplify 4 squared. 4 squared is 4 times 4, which gives you 16, x to the 6th. Here's another one that's a little more challenging. So we have a product inside of all these. So 4, let's go up here, 4 times x times y cubed, all of these squared. So I'm going to take this squared to both. Now, it's so important for you guys to understand that this is multiplication. What is going on inside this is multiplication. So that is why we can just distribute this squared to all of them. Okay? We're going to see later on with different, if like addition and subtraction was in between these, you cannot do it. That's when you'd have to FOIL. But because this is multiplication, you can just distribute that 2 to both. So we have 4 squared, x squared, power raised to a power. What do? We are going to multiply them. So they've started simplifying this out for us to look at. Like I said, they took this 2, gave it to their 4, gave it to the x, gave it to the y cubed. And you can see that here. Now, this negative 3, power raised to a power, what are we going to do? Alright, here we had power raised to a power first. 3 times 2 is 6. You can see that here. Now, 3 times negative 3, it's going to give me negative 9. So that's that first part of today's lesson. Continue to simplify. We can rearrange these because it's multiplication, that community property of multiplication, rearrange them around. 4 squared, I brought down. X, my like terms here, x squared and x ninth, and then my y to the 6th. Like terms, they have the same base. So because they have the same base, we can do what with their exponents from yesterday's lesson? Yes, you add them. 2 plus negative 9. 2 plus negative 9. It's going to give me my negative 7. Bring down y to the 6th because there's no other y's, so that's my only like term. And x squared is the same. X squared is really 16. X to the negative 7, y to the 6th. From previous lessons, we know this negative here, we do not like. We got to kick that to the bottom. So on top, I'm still going to have 16 y to the 6th. But on bottom, I have to kick my x to the 7th. And notice I lost the negative sign. That's that whole piece of putting it 1 over all that. But 1 times, this is still going to give me this. So that's why that's left by itself. So simplified answer is 16 times y to the 6th all over x to the 7th. That is the end of today's lesson.